Okay, one more video, I think. So here's another part 3 of that example. I decided to make the rod 20. Whoops, come on. The rod is now 20 kilograms, but the mass is ignored. Not a big difference, but some. So I will draw out the FBD and the IBD and put these on here. Now it's going to have the same values as I had in the previous problem. Some of this formulation is going to be a bit different. So we got Roy and rocks. Right here in the middle of Mg and the rod. We have a little bit higher. We have we have 2 FD and 2 FC. It didn't really matter which way we went for the thing. And we're going to have, actually I like that dashed a little bit. Oh, okay. So something we want to do here. I'm sorry. Before we go any further, we know that the I about the bar is 1/12 ml squared. That's the moment of inertia about the center. But now if we want to go IO, parallel axis theorem is M, and I usually use D squared. So D in this case is going to be the distance that we have to move, which is 1/2 L, right? So that goes IO is equal to 1/12 ml squared plus m L over 2. That's the distance we have to move from the center of this thing to O squared. And if you have IO 1/12 ml squared plus 1/4 ml squared, the common denominator is 12 right here. So we could turn this into 3 12s, right? That 1/4, that's 1/4 now. And so IO is equal to 1/3 ml squared. And many people will just memorize that because it comes up a lot. So we went IO theta double dot. So if we do the sum of the moments about O equals the sum of the moments effect. No, not. I'm sorry, my bad. We did this. The whole purpose is just to demonstrate that we could do this instead. That we put this right in there. So I'm writing this out, even though I don't want to. It's going to go 2k times L minus A squared theta plus 2 times C L minus A squared theta dot minus L over 2. I guess maybe I go, yeah, I guess L over 2. I don't know why. I put a 1/2 in there, but I guess it's L over 2 mg theta equals negative 1/3 ml squared theta double dot. So we go back to the equation of motion, and we could skip a step just by dividing the thing throughout, right? I could be this is if I'm not lazy and I'm tired. I've been here way more hours than I'm supposed to, but that's okay. Mrs. Deal will be okay with it. She's cool. L minus A squared theta dot, oops, get that out of the way, plus 2k L minus A squared minus 1/2, I guess, mgl theta equals 0. right? So that would be a long equation of motion. We could shorten it down. Theta double dot plus 6 C L minus A squared over ML squared. Theta dot plus, I go 6K L minus A squared minus 3 halves MGL over ML squared. And theta. Okay, so one thing that we could do, because we're dealing with numbers, is we could plug in the values. And I'm not going to show you where I'm plugging values. I'll instead just write this out. Go plus, and then this whole thing is 0.09600. I put in all those values from the previous problem. Putting all those values in. Theta dot plus, and then I put all those values right here, and I get 18.57. Theta equals 0. This is probably a better equation of motion. And then I take my lambda, I do this subst. Theta equals e to the lambda t. And I take my lambdas. Okay, well, I could just go lambda squared plus 0.09600 lambda plus 18.57 equals 0. And then I go find the roots. And I find the roots on the next page. And I get lambda 1, 2 is equal to negative 0.09600 divided by 2 plus or minus square root of 0.09600 divided by 2 squared minus 18.57. And this whole thing becomes the omega d that I have for it, and except that we have to make sure that we reverse the sign in there. We get negative 4.309 radians per second. Then the period is going to be 2 pi over omega d. 2 pi over 4.309. Oh, and by the way, I think I changed the mass along the way, right? I think at this one right here, the mass was 20 kilograms as opposed to the mass at the top is 10 kilograms. So it's not really we could compare them. I mean, it doesn't matter. We just keep that in mind when you look at the comparison. But we have the time as 2 times tau d, and that comes out to 2.916 seconds. So a lot of example problems, and we also have the suggested problems that you work through. There are a lot of problems. I feel like you have enough to do great. So this was just another problem. This was 3.58 seconds for 2 cycles compared to 2.916. Granted, we have a 20-pound or 20-kilogram bar as opposed to having a 10-kilogram mass at the top. So maybe I should have made this 10 kilograms right there. So it was probably just an oversight on my part. Finished. And how many hours have I been at the University of Hartford today? Let's take a look. I got here at 7:30 this morning, and it is almost 11 o'clock. I can't even do that math. So that would be 11 hours plus 4.5. So that's 15.5 hours. That's impressive, man. I should get some kind of award, like, I don't know, promotion and tenure. Oh, I already got that. Good night.